Hello everyone, how are you? I hope all of you are doing very fine with your preparation and all of you are eagerly waiting for the JEE Advance or JEE Main exam to be finished as soon as possible. I understand this. Keeping that in mind, I'm giving you one video in which, as you can see on your screen, there is a question of integration of indefinite integration indeed, and this question is indeed very tricky. This question is indeed very tricky, keeping the level of JEE Advance in mind. So if you try this question, if you want to try this question, you can directly pause this video right here. I think you should attempt this question right here first of all yourself. If you could not solve this question, only then you should watch the solution. Now, if you are interested in watching the solution, then I'm solving this question for you. Wait a minute. Just look at the question. Look at the sum of the integration. Whatever is given is there are infinitely many nested radicals. You can see we say that these are nested radicals. A radical inside another radical inside another radical. So x multiplied by square root of x multiplied by square root of cube root of x multiplied by fourth root of x multiplied by fifth root of x, and so on up to infinitely many terms are there inside, and then we have to integrate it with respect to x. So if you see that the outermost x, the power of outermost x is 1, then the power of the second x that is inside the square root is 1 by 2, then power of third x which is inside the cube root is, obviously there are two radicals above the third x, so if I write them in index form, then it will be x to the power 1 by 2 into 3. Similarly, the power of the next x will be x to the power 1 by 2 into 3 into 4, and so on. We have to integrate this term. Now if you see, then we can simply add the powers of the x, and 1 by 2 can be written as you know, 1 by 2 can be written as 1 by 2 factorial also, because 1 by 2 is equal to 1 by 1 into 2. Similarly, 1 by 2 into 3 can be written as 1 by 3 factorial, because it is equal to 1 into 2 into 3 is 3 factorial. Similarly, next is 1 by 4 factorial, and so on infinitely many terms. As you can see here, it will go up to infinity. So as you can see, x to the power 1 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial plus dot up to infinity. Now this series should be very convenient for you to recall. This series is a very popular series, and that is called, this is the expansion of e to the power x when x is equal to 1. No. When in fact it is e to the power x minus 1 when x is equal to 1. So we can write it as e to the power e minus 1 dx. As you know that Euler constant, that is e, is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus dot and so on up to infinitely many terms. So if I derive 1 plus 1 by 2 factorial plus 1 by 3 factorial and so on, that should be equal to e minus 1. So I replaced that entire series by e minus 1. And now this is a very easy sum. Now after doing this much step, this is now very easy. The integration of x to the power n dx, as we know. So finally this should be x to the power e divided by e plus constant of integration. So this is as simple as this question, but when you face the question for the first time, indeed this question is literally tricky. Once you have cracked the concept behind the question, then this is nothing. But until and unless you are able to find the core concept behind this question is indeed very tricky. And as you can see, I have solved. I'm again showing you from the step 1, and from step 1. So first step is this. Similarly, second step and third step and so on. So as you can see, the steps involved in this are very less, but the concept behind the question is indeed very nice, deeper concept, and question is solved. So if you like the solution, don't forget to like the video. Please, if you want to say something, you can say in the comment box, and if you wish to share with your friends, then you can share the video. Learn the solution, learn the core concept behind